Hey everyone, this is Mr. Jakis and math instructor at Yavapai College, and welcome to our section 6.2 video. So I'm going to go ahead and share my screen and we'll get into the video here. All right, so section 6.2 is on factoring trinomials with a leading coefficient actually of 1. So there's no leading coefficient here in front of the x squared. That will change next section to an ax squared plus bx plus c. Some objectives here. So we're going to review binomial multiplication, factoring trinomials with a leading coefficient of 1, like I just said, and then other sort of related geometry things if I had that planned, pretty sure. So anyway, not that I don't know what I have planned, I just want to make sure. But okay, so factoring not ax squared, just factoring x squared plus bx plus c. So this section is a little bit easier than 6.3 because we don't have the leading coefficient there. But basically when we do this, we want to find numbers that satisfy, so maybe numbers m and n. I might use different variables to represent those, but we want to say that m times n equals c, and then the sum of those is b, and that'll make more sense here in a second. But basically, we want to start with a polynomial that has 3 terms, and we want to factor it so that it has 2 expressions with 2 terms. All right, so let's just recall some things and some examples. So if we recall, when we multiply x plus 7 times x minus 4, right? How do we do that, right? Well, we do something called FOIL, right? So we take remember FOIL, right? We take the first terms and then times the last terms times the inside first outside terms inside then last, okay? So I could do x times x is x squared. Outside terms x times -4, right? Keep the negative. 7 times x is 7x, and then 7 times -4 is -28. And then once I do that, I can combine these 2 terms because they're like terms, right? They both have an x, and -4x plus 7x is 3x, and that would be foiling it, okay? So, but here what we want to do is we want to start with the x squared plus 3x minus 28 and find factors so that it's x plus 7 times x minus 4. We want to kind of work backwards. And here's how it works, okay? And I just have a couple of different examples here to start us out. One is easier, one's harder. But basically, when we do these, and this will make more sense when we have the a or a leading coefficient in front, but our leading coefficient here is going to be 1 unless we have something like this where we're going to have to factor out a GCF first. Okay, and same rule as last section, always factor out a GCF first if you can. That just makes everything easier. But anyway, what we do here is we take the outside number times the inside, outside numbers and multiply them by themselves. I'm getting confused with FOIL. But so 1 times 24, I'll just start it up here as 24, okay? And what we're looking for, and I'll kind of make a factor tree, is we need factors of 24 that add to 11, okay? Well, what are factors of 24? Well, of course, 1 and 24, 2 and 12, and 3 and 8. Oh, and also 4 and 6, okay? But I want 2 of these so that they multiply to give me positive 24, which they do, but add to give me positive 11, okay? And we know that positive 3 and a positive 8, right? We know 3 plus 8 equals 11, okay? So that's what I'm going to use. And when I do this, some people find this helpful. I can make little factor trees here once I know what my factors are. And then so I know x squared breaks down into x times x, and 24 is 3 times 8. Well, I just use those then when I make these factors. okay? So x plus 3 times x plus 8. And if you're unsure of that, how can you check it? How can you check it? Well, we would FOIL it, okay? And I can do that here, right? X times x is x squared. X times 8 is 8x. 3 times x is 3x. And 3 times 8 is 24. And that equals what I originally started with when I combined like terms of 8x and 3x. So I know that I did it right. So this checks out, okay? But here's my answer. All right, and the next one, I might need a little more room. I might just start this one up here. But notice right away, I have 3 coefficients, -3, 9, and 210. And I think 3 definitely goes into 9, and I believe it also goes into 210. It does, it goes in there 70 times. So I can actually, I'm going to take out a -3. And actually, not only that, I'm also going to take out an a because I have an a cubed, a squared, and an a. So I'm going to take out, whoops, I'm going to take out an a. So -3a. When I take that out of this one, I have an a squared left over. I have a -3a to give me that positive 9a squared when I distribute. And then I have a -70. And now notice that this polynomial, right, can be factored. How do I know that? Well, again, I'm multiplying the 1 and the -70 to give me -70. I need factors of -70, right? 2 numbers that multiply to give me -70 that add to this middle number of -3, okay? So let's do that. So I have, well, 1 and 70, really, it would be either a -1 or a -70. I'll worry about positives and negatives later. 2 and 35, that definitely doesn't give me a 3. What else is there? Well, I know there's 5 and what would that be? 5 and 14, that's still not going to give me 3, and then 7 and 10, maybe there's other factors. But I know that a 7 plus -10, 7 plus -10 does give me the -3 that I'm looking for. So these are my 2 numbers that I want. So then in my, sorry, this is all over the place. I didn't give myself enough space to write. But basically, I have my numbers here, 7 and -10, and then I have the a's in there. So I have -3 times a plus 7 times a minus 10. And again, you could multiply this out, so you can multiply, or I'm just going to work the -3a into the first term here, a plus, or the first polynomial, a plus 7. And then times that answer by a minus 10, you should get this guy. All right, these are a lot easier than the last one that we just did, but I wanted to give you some practice, maybe more on your own. So if you want to pause and try to do these, you can. But I actually just kind of kept in some of the notes here and didn't like this. Actually, let me go back. So if you want to take x squared plus 11x plus 18, again, you want factors of 18 whose sum or who add to 11, however you want to say it. Factors of 18 are 1 and 18, 2 and 9, 3 and 6. If you like organizing this in a table, you can definitely do that. These add to 19, 2 and 9 add to 11, 3 and 6 add to 9. We wanted the ones that add to 11. So here's my answer, x plus 2 times x plus 9. So our next trinomial here is x squared plus 10x plus 24. Again, I want factors of 24 whose sum is 10. So if you want, you can make a table like they did here. And then we know that 4 plus 6 is equal to 10, and those are going to end up working out for our 2 factors. X plus 4 times x plus 6 is the answer for that one. All right, now we get into some that have negative signs here. So it gets a little more tricky, but not too bad. So again, if I had a coefficient here, I would take this times the 14, but I don't have to do that, okay? It's just 1 times 14, which is 14. So I need factors of two numbers that multiply to give me 14 that add, or whose sum is -9. Okay, so what are some factors of 14? So I like to do the factor tree. The book likes to do the table, whatever works for you. But really all we have is 1 and 14 and 2 and 7. And remember, these have to add to -9. Well, I know that -2 plus -7 gives me a -9. So my two factors are x minus 2 and x minus 7. And if it helps you out, you can make your little factor tree, x and x, and then -2 and -7. Some people like to do it like that. So then if I were doing it that way, for this one, you could try that. I won't write all this out, but I have x and x. And you could think in your head, two factors or two numbers that multiply to give me 48 that add to give me a -19. And I know that that would be -3 and a -16. So these multiply to give me +48, but add to give me -19. So I know my answer is x minus 3 times x minus 16. All right, let's go on. So factor each trinomial. These ones now, the positive, or this one at least, the positive and negative switch. That's why I'm showing all these examples. So now I want factors that multiply to give me -15, but add to give me +2. So again, in my factor tree, I'm going to start with a -15. What are factors of 15? Well, 1 and 15 and 3 and 5. I want them to add to give me +2. So I need, well, it's definitely not 1 and 15, but I need the 3 to be negative and the 5 to be positive. So my answer there is x minus 3 times x plus 5. And again, you can check it by foiling, okay? And that should work out for us. And then for this one, I need factors of, again, 1 times -16, -16 that add to give me -6. Well, let's try that. Factors of 16, 1 and 16, 2 and 8, 4 and 4. 1 and 16 aren't going to work. 4 and 4 are never going to give me a -6, but 2 and 8 will if 2 is positive and 8 is negative. So then my answer there is x plus 2 and x minus 8. All right, what about the next one? Factor this trinomial, okay? So the only difference here is actually, oh, I thought it was the same. Never mind, I changed a couple different things. But if this one is x squared plus 6x minus 8, I need factors of -8 whose sum is +6. And there's a reason why I'm writing these out twice. But let's go through all the options here. So they have to multiply to give me -8. Well, the only two ways that can happen is -1 times +8, or 1 times -8, or -2 times +4, or +2 times -4. Those are the only 4 options. But the only thing is, once you've gone through all the options, do any of these add to 6? Well, -1 and 8 add to 7. 1 and -8 add to -7. -2 and 4 add to +2. 2 and -4 add to -2. So none of these add, none add to +6. Well, that means that the trinomial just means it has 3 terms. The trinomial is prime. It has no other factors but 1 in itself. That's what prime means. The only thing you could take out of this is a 1. Well, that just doesn't really help us, okay? So it's prime. All right, couple more examples here, and then we'll have sort of a geometry type question. So in factoring these trinomials, what I really want you to focus on is recognizing if you can take out a GCF first, okay? So really it's recognizing, can you find a GCF? That really should be your first question all the time when you're looking at these. And I can factor something out here, right? I do have a greatest common factor, and that would be 4 in all of these, right? 4 goes into 4, 4 does go into 28, and 4 goes into 48. So I take out a 4 or factor out a 4. I'm left with 4 times quantity x squared plus 7x plus 12. And now I just worry about factoring this part, right? Factoring this trinomial. So I want factors or two numbers that add, or sorry, two numbers that multiply to 12 that add to 7, right? So if you want to do that kind of off to the side, you can. I know it's going to be a positive 3, positive 4. So then my two factors are going to be x plus 3 and x plus 4. Again, you can check this. Okay, how do you check it? Well, distribute the 4 in here, right? That's your first step. So it would be 4x time, or sorry, 4 times x is 4x. 4 times 3 is 12. So that would be one expression. And now when you check it, now you're going to have to FOIL. So I'm going to take 4x times, whoops, definitely, that's what I'm talking about. I talked about that in another video with my silly writing tablet here. But I take 4x times x, which is 4x squared. I take 4x times 3, which is 12x. 12x times x is 12x. And then 12. What did I do wrong here? And tell me what I did wrong. It's not working out because 12 times 3 is 36. I'm not getting what I started with. What did I do wrong? Okay, took out that. Let's see. Oh, I'm blanking right now. What did I do? Let's see, 4x squared. We have a 12. So we took out a 4 from this. So that is 4 times x squared is 4x squared. 4 times 7x is 28x. 4 times 12 is 28. Now we left the 4 out here and we factored this. We wanted factors of 12 that added to positive 7, which are 3 and 4. So that should be correct. Now I distributed the 4 in, so it's 4x and then a 12. Okay. Now I do 4x times x is 4x squared. 4x times 3 is 12x. 12x times x is 12x. 12 times 3. Oh, you know what? I think I'm working backwards. I'm working backwards. I don't need to. I know what I was doing. I was kind of yeah, I was this. Okay, this is your answer, right? That's your answer. And then let me just come back to that. Okay, let me come back to that one. Let's do this one. So this one I can find a GCF here of 7. And then here I need factors of -10 that add to positive 3, which are 5 and -2. So I have 7 times x plus 5 times x minus 2, and that is the answer. That's the answer. So that's kind of how you factor those. Let me check this one. I'm not sure. I don't know. Some reason I'm just not seeing what I did wrong in, oh, yeah, in that question. I'm not sure what's going on. Anyway, let me go to this one. So this one I check it. I do 7 times x is 7x. 7 times 5 is 35. And then check it, and I get 7x squared minus 7x times -2 is 14x. 35x, -70. And that one checks out. I'll tell you what, if you can tell me what I did wrong in this video, just send me an email and I'll give you a couple points of extra credit. For some reason, my brain is blanking and I'm just not seeing what I did wrong, and that can happen sometimes. So let me know. I'll give you some extra credit. You can reference the video. All right, last one. Find one possibility for the dimensions of a rectangle that have an area of x squared plus 12x plus 35. So dimensions of a rectangle. This is the area. So A, or area, equals x squared plus 12x plus 35. If you recall from geometry, you know that the area of a rectangle is equal to the length, right, times the width, or A equals L times W, right? So basically, if this can be factored into two different things, then I have a possibility for the length and the width. And it can, because 35 can be factored into 5 times 7, which both add to 12. So the length, one possibility could be x plus 5, and the width could be x plus 7, or vice versa. So if I have a rectangle with an area of x squared plus 12x plus 35, a possibility for the length could be x plus 5. Possibility for the width could be x plus 7. By the way, I just have it drawn that the length is longer than the width. I could have switched these around. It doesn't really matter. Okay, so that is basically the answer. Okay, so one possibility for the width could be x plus 5. One possibility for the length could be x plus 7. Now, after this video, I'm going to go through that one problem that for some reason, I don't know what the deal is, I cannot see what I did wrong. But again, if you tell me what is wrong, I'll give you a couple points extra credit toward either your homework or a quiz or something like that. So we'll figure that out if anyone sends me an email. So have a good rest of your day, and we'll see you for section 6.3.